All right, guys, let's do number 25. And also, we're going to do number 26 at the same time. So, in fact, I'm going to pull the solution manual on the other one. So, the driver of a car slams the brakes when he sees a tree. So here you have a car. It has to be traveling at some velocity, which we don't know. Or in this case, we'll call it V naught. I don't really care. And then, and then and it's going to have an acceleration of 5.60 centimeters per second squared. So in other words, the driver slams the brakes when he sees a tree blocking the road. The driver slams the brakes. So the car slows uniformly with the acceleration of this, which is, oh my god, I wrote it so sloppy, for 4.2 seconds, making a straight skid 62.4 meters. So you're, imagine you're in the car and you're an idiot, and there's a tree happen to be in front of you, and you press the brakes at 5.60 centimeters per second square, and when t equals 0 seconds, you start at this point, and t equals 4.20 seconds, you hit the tree, and that's all, folks. And then it makes it a little skid row for 62.4. So I'm going to say x equals 62.4 meters. And notice that I'm just getting the setup. And I should probably edit parts of this video, but it might make it a bit shorter, but that's all right. So the driver of the car, okay, so you're driving a car, you see a tree, you hit the brakes. I mean, you see a tree, you hit the brakes, and then you hit the tree. So that's all the visual we need. All right, now let's solve whatever the heck it's asking. With what speed does the car then strike the tree? Well, we don't know the initial speed, but we are given this equation. This is going to be the standard equation. When x equals 0 meters, let's just put 0 meters, not that you have to put that, plus some initial velocity, which we don't know, times the time, minus 5.60 centimeters per second square, divided by 2t squared. So this is the motion graph, where the condition is you have the initial velocity and the final, and which you don't have the initial velocity. Okay, I think I need to slow down here. I am a bit higher in the edibles right now. So anyway, so all right. So it's asking for the final speed equals some initial speed minus 5.60 meters per second square, and t. All right. So let's do some. All right, guys. So you are given two equations. But what I'm gonna do here on the side is I'm gonna write the equation here: x equals x naught plus v naught t plus at squared over 2. And then I'm going to take the other equation, b naught plus at, and what I'm going to do, and so the only so we have t, we have a, we have the acceleration, and what else we're giving? Oh, and the time it takes so we have t and we have x. The only equation is the unknown. You have two equations, two unknowns, v naught and b. So what we're going to be doing is taking that v naught, solving for that, and then plugging it in there. So once you do that, so x, or in this case I'm going to call it change of x, is going to be v minus at times the t plus at squared over 2. So now you have change of x equals vt minus at squared plus at squared over 2. So here you take the 2 over 2. So now you have the change of x equals what the heck did I do? I think I did it correctly. I'm just confused. I'm just like not sure where I went wrong. So anyways, the whole point is to get to that equation, folks. So here you have x plus at squared over 2 divided by t. This is the equation that we're going to be using. So here you're going to have 62.4 meters plus, minus 5 points. The acceleration is 5.60 meters per second square divided by 2 times the 4.2 seconds square all over the 4.2 seconds. So now all you have to do, folks, is put this in the TI-84 calculator. And here you get the speed of 3.10 seconds.